Okay, so we are talking about the Sierra Nevada range. So this area in here, if you have ever been to Mammoth, Lake Tahoe, Bishop, that area, Mount Whitney, that's the Sierra Nevada mountain range. And so we're going to talk about how that formed and why it formed. So if we're keeping it here, if we look back at this, these mineral grains are very large to where we can see them. So this is a phaneritic rock. Top four. Very popular with countertops and whatnot. So typical composition of a granite, you have these large minerals. We're going to talk about why that is in a second. But so these large pink ones in there, those are called feldspar. So I'll write it in. It's not that important to know, but it's nice to know. These black elongated, these black flat ones, if you remember from our mineral lab, these are biotite. It's a mica, a flat, sheety one. These elongated ones are called hornblende. And then there's also a little bit, some of these other, let's find a good spot. Like this gray area in there, that's quartz. It makes up part of granite. So that's the typical composition of a rock in the Sierra Nevada mountains. So we're going to get to a couple terms. Let's hop to those. So now, next one we look at igneous, meaning born of magma. So we have three different types of rocks: igneous, metamorphic, and sedimentary. Igneous is the only type that comes straight from the magma. And so that granite, that is a igneous rock. Plutonic, so the granite is plutonic as well, so it's a plutonic igneous rock, which means that it cooled underneath Earth's surface. Put a comma there. This is important because it is, since it had a long time to cool, that it can become phaneritic, where the minerals are large enough to see. And we talked about batholith, so a very large body of rock. And I say very large, meaning it covers, that whole area of the Sierra Nevadas, and then partially out into Nevada and up into Idaho. So very, very large. But those are important for us to see. So let's hop forward. So this is pulled straight out of a California geology textbook. And we want to talk about how the Sierra Nevadas formed. So we have this diagram here. So we had talked a little bit in class about subduction. So right here we have this plate that is being subducted underneath. Well, let's name these. This would be the Farallon plate, which we talked about, and this is the Pacific plate, which most of the country resides on. So we have the Farallon plate here, which is this dense oceanic plate that encounters the Pacific plate, which is continental crust, which is much lighter. And so, let me go to the laser pointer here. So if we look, we have this light continental crust and this heavy oceanic crust. And so what's going to happen when they encounter is this oceanic crust is going to dip down below because it's much heavier. And this continental crust on the Pacific plate is going to override it. Now, what that will do is, first off, we're going to get like this big buildup in here. This is called accretion. And it's just going to scrape all this stuff off the edge of the plate that's going down. And it builds up. Then also, as this plate goes down, it goes further into the earth, it heats up. And so once it heats up, it melts. And because of the density difference, that melted material rises. And that's what creates these volcanoes around the Sierra Nevadas. And so when we talked about those plates, that is what sort of created the volcanic events that led to the Sierra Nevadas. Because you had this giant pooling of magma to create what's called the Sierra batholith. So this big, gigantic body of magma, which was just, some of it was coming out as volcanic rock, some of it was just cooling. And that's where our granites are forming, right in here. So let's continue. Blank slide here. I don't think there's anything else we need to cover. So let's hop to the next slide. And so this is what we kind of have. So these, in here, this is your Sierra Nevadas. And this is the western part of it. And so we saw back on that other slide, as that one plate was sliding below the other, and we had that little buildup. So we have this area of buildup, which is this in, let me use the laser pointer, this area in here, where this is being pushed up, and then it gets to a point where it fractures and there's a fault. And this sharp fault in here is what creates the Sierra Nevadas. So this whole area in here, the plate is being pushed, and it's being forced up because there's nowhere else to go, and we get the Sierra Nevadas. Look at the next one. So when I talked about the Sierra Nevadas being a gigantic body of magma, this whole area in here, all the black you see, and I went a little bit too far down, but pretty much that area in there, and even this is speculative, but it's all part of that batholith. So this is a gigantic body of magma. We're talking about most of California into Nevada and some into Idaho. So that gigantic batholith of magma that was down below. So now let's hop to the next slide. And so let's think about what that does. So we had that area where we had the Sierra Nevada, so those volcanoes, right? And we had this batholith of magma down below. So there's our magma. And so what happened is everything above, so all this area in here, over time, because we're talking about millions of years, right? So over millions of years, these mountains would undergo erosion. So it would be kind of weathered away, until eventually, let's hop to the next slide, it would be exposed. So this batholith in here, let's put BT for batholith, it gets exposed. So now that whole area has been weathered away, and we have these gigantic Sierra Nevada mountains. Bad drawings, go another. So we have that gentle western slope and that deep dip off. And so this whole area now is just that granite that has had so much time to cool down below that is now exposed at the surface. And there we have our Sierra Nevadas. And now you're going to get to sort of tell the story of it and see how they formed.